Hello, everyone. My name is Brad Erickson. I'm a radiologist at the Mayo Clinic, and I'm going to talk about imaging AI on the cloud. I am involved with a startup that does AI process automation, but I don't plan to discuss that today. Business has become very excited about the possibility of cloud computing. You can see that some of them are using public cloud resources, private cloud resources. Most are pursuing a hybrid approach. But nevertheless, cloud computing is having a dramatic impact on how we solve computing problems today. There are a number of reasons why cloud computing is so interesting. The first one being scalability. We all hear about the massive computing resources in cloud computing. Some also have called it elastic cloud computing, which means it can stretch to essentially any size to solve the problems that you have. Generally, the charge for cloud computing is more or less a function of the amount of time that you use it times the amount of computing resource, which for deep learning, we're basically talking number of GPUs. So the charge for 100 hours on one GPU is more or less the same charge as 1 hour on 100 GPUs. And if you got something like perfect linearity of your algorithm, that means that you would pay the same to get a problem solved in 1 hour compared to 100 hours. That's a huge advantage. So if you need a result fast, cloud is a great option. Another advantage for cloud computing is access, and never has this been more true than during the current COVID pandemic. User access is essentially possible anywhere in the world that you have internet. Another advantage is data access, and this is perhaps not so widely appreciated, but if you have one gold copy of the data, such as all of TCGA and TCIA with any updates present in one location, that can be a huge advantage, particularly if you are starting to add things like annotations from multiple sites. Those are so easily shared compared to the challenges of updating it across to many sites. Cost can also be an advantage depending on your situation. Cloud computing essentially converts capital expenditure to operational expenditure. Now, the total cost will be heavily dependent on the way that you use your computing resource. If you are constantly using the server 24 by 7, days, weeks, months at a time, you will have cost parity at about 9 months. In other words, you will pay as much for cloud computing to run it for about 9 months, 24/7, as you would pay to have purchased that system. So after something like 9 months, and again, that number is highly variable depending on the specific GPUs that you buy and so on. But just consider that somewhere around that time period, you could have purchased your own servers and then essentially have them free afterward. But there are many advantages to cloud in that you can, for instance, do something like buy the base. If you know you're always going to be computing at a certain level, then yeah, go ahead and buy servers to address that. But anytime you have specific needs that go beyond the base, then you rent the peak, which means go out and use cloud computing when you need something fast. And remember, there are a lot of costs that are easily forgotten. There is no downtime, so all the costs associated with fixing the problem, with not having results when you thought you had them, and recovering any data lost during that period is a big advantage. If you go down in the middle of a compute, well, you've lost everything probably. You also have no data center costs, so that means no space, no power, no cooling, a big advantage. And it's widely accessible. Again, in these days of COVID, that is much more appreciated now. Security can also be an advantage. Yes, obviously the cloud is accessible to anybody, including all the hackers, but there can be a big advantage in that cloud computing is designed from the start to be secure. And because these are huge companies, they can hire teams of security experts, typically a lot more people than what a hospital can hire. Now, one thing you have to be careful with is that you typically will want to layer your security on top of that and integrate it with the security provided by the cloud provider. And that could be challenging. So at least you need to think about it and talk with the vendor to understand how to do that well. There are several ways that you could have a disaster happen, and so you need to think about disaster recovery and failure types even with cloud. If you think about hardware failures, there usually are other data centers provided by that cloud vendor that can be accessed during an outage. And depending on how you configure your build, you potentially could have it automatically migrate from one data center to another so that you may not even experience any significant downtime. Remember that fixing the outage is the responsibility of the cloud vendor, so you can focus on what you need to focus on during that downtime, and the vendor will be spending their resources to get the outage addressed. And these outages are rare. You know, if Amazon or Google goes down, you hear about it in the news, and it's pretty rare to hear about it. So generally, they do a pretty good job. In terms of software, system software is a vendor responsibility. So the operating system, if you're running a database, they're going to take care of the actual database operations. And then typically, then you would load your software, the specific application you have, as a container. So you have an image that can be versioned and that you can go back to if you have some sort of a problem. I'll talk about this that it's important for developers, for instance, to have their development environment exist as an image so that if they have some sort of a bug that they introduce or they errantly write across a bunch of data, they can just go back to an earlier snapshot of their development environment and be up and running in minutes compared to having to fix that system under their desk. In terms of data, the storage generally is quite reliable and generally the vendor can recover it quite quickly. The major risk now really is actually a logical error. In other words, overwriting good data with bad data. But cloud has great capabilities for doing snapshotting where they take a picture of all your data and save it out. And then every so often they update the snapshots so you can go back to a relatively recent time point where all the data is good and you can get pretty fast recovery through that mechanism. Cloud computing can also help with project management. Cloud vendors generally have good tools for project cost estimation and for tracking those costs. You can also adjust the project timeline and cost by changing the cloud model. So you can, for instance, say, I want to be guaranteed access to X computing resource, say 30 GPUs or whatever. But the cloud vendors also offer what they call preemptive models. In other words, if somebody pays more, that they get access to the GPU, but once they're done, then you get it. And the cost discount can be substantial on that. So if you can slow things down a bit, you can save a lot of money. And then also it can allow for a better development environment. This goes to the idea of snapshotting your development environment so that if you have any problem, you can immediately go back to the previous day's work and recover from there. So hopefully you've piqued your interest in using cloud computing, and there are several good ways to start. There are a number of cloud-based GPU-enabled computing environments out there. Perhaps the most popular is Colab from Google, but there are other ones like Paperspace and Floyd Hub. There are more every day. Most of these actually package AWS or Google and provide a better user experience. So look around at them. Some of those may be very good for what you want to do. Some or most actually allow long-term storage at a price as well as high-end multiple GPUs, again, because they leverage companies like Amazon or Google. The cost is highly variable across these different services. They range from free for Google Colab on up to higher expenditures, and this is a somewhat outdated chart. Now we have newer processors beyond the V100, the P100, and now the A100. So you're going to have a cost that depends a lot on how you need to train your system. If you're interested in trying this, I'd encourage you to start with something like Colab. You can see the link there, https://colab.research.google.com. If you then click Open and open GitHub, search for Imaging Data Commons, and then look for IDC-examples And a good notebook to start with is LIDC Exploration. When you open that notebook, it will tell you some of the prerequisites. Obviously, you need to have internet access. You need to have a Google identity. Basically, that means having Gmail. You have to configure a project, and there's a video there that shows very nicely how to do that. And then once you create a project, you'll get a project ID. So for instance, I created one, that's the project ID, and that needs to be pasted in. And once you paste that into the notebook, you'll be able to run the rest of the notebook. And here are just a few screen grabs from me running that LIDC example one. You can see it does a number of queries to find out what sort of data is out there for LIDC, as well as the various types of annotations. So I think cloud is a superb environment for large and complex data sets. Also, anytime that the data is being updated, particularly across multiple sites. I think cloud is superb for a development environment because you can immediately go back to a prior snapshot, and cloud is good for pulsatile training needs. Remember that saying, buy the base and rent the peak. I hope you found this helpful and that you do some exploration of the IDC. This is going to be a great resource for the imaging community. Thank you.